Today I am going to discuss about measurement of power. Okay, so before starting the basic slides about the measurement of power, so we need to know the motivations of this chapter. Okay, so why the measurement of power is important and what is the basic motivations and how we are doing this process. Okay, so first I have one by one. I have covered a lot of things. Okay, so what is the basic instrumentations? For after that, I discussed different calibrations and standardizations of the instruments. Then how it is working. Okay, so lot of things have already been discussed. Okay, so different measuring process. Okay, so measuring procedures. So basically you know that that all the parameters. Okay, so all the parameters are important for the measurement purpose. Okay, so also that power is also important because of what, because if you know that current days we are using we are consuming the power. Okay, we are consuming the power in domestic applications, okay, as well as commercial applications. Okay, means you are using the power. Power is very important issues and you are using the power in different places, maybe domestic, industrial. Okay, then different because of what, all the appliances you are using in your home, maybe home appliances, maybe industrial, so definitely it will consume some power. Okay, so definitely if power means it's not like only active power. Power definitely related to the reactive power also. Okay, so if you able to measure the total power, if you are able to measure the total that means how much power, active power is drawn by the system, and if you have the total measurement, VA measurement is there, so you are automatically able to receive or calculate the reactive power. Okay, so measurement of the reactive power is another most important issue, because of what, because if you maintain the reactive power profile. Okay, so if the reactive power profile has been maintained by your side, so there will be no problem, means always voltage profile will be fixed. Okay, if the reactive power profile is always time variant, means changing with the time, and it is high demand of the reactive power, definitely it will it will decrease the, that means demand. If the reactive power demand is too high, so definitely the power factor will be, you know that power factor angle. Okay, so there is some relation between the active power and the reactive power. Okay, so if there is changing of the power factor, so definitely losses will be increased. So measurement of power in terms of active power, in terms of reactive power, so that is very important thing. Okay, so that's why we have to much more bothered about the how to measurement the power and which method we are going to be followed for the measurement of the power. Everything is important. Okay, so that's why that's why the measurement of power is important chapter for our measurement electrical and electronics measurement curriculum. Okay, because power measurement, if you don't able to measure the power accurate manner, so you are not able to measure that energy, because energy is then integrating factor of your power. Okay, so if you multiply with the time with your power, so definitely you will get that energy. So energy is another important issue. Okay, so measurement of power, so it's energy is a function of power. Okay, so that's why measurement of energy, when you are going to be when you are doing that measurement of energy, so in that case power measurement also very useful. Okay, so you have to use some method. Okay, so after that you are using some integrating instruments. Okay, where you are doing the multiplications. Okay, with the multiplication of time with your power, so in that case you are able to measure it. So I think all of you are able to understand what is the importance of that measurement of power. Okay, so basically you have to maintain that voltage profile. So reactive power, how much reactive power is drawing by that instrument, okay, or the appliance, how much active power demand is there, because all the cases active power and reactive power always maintaining the power factor. Okay, so power factor you have to all the time you have to maintain the power factor should be nearer to the unity. Okay, anyhow, any drooping or any reducing value of power factor may cause some additional losses. Okay, so again that reactive power profile is changing means definitely unwanted harmonics. Okay, lot of things, lot of problem may be observed over here. So that's why measurement of power is so important, and in this chapter we will discuss about how we are doing this process, means how we are doing the measurement process for the power, means power measurement process. Okay, and what are the normal other issues, like means other normal issues, means you can follow just for a moment. Okay, so one important call is coming. Okay. Hello. Okay. So I think all of you are able to understand the importance of that power measurement. Okay. So here, I have already told about that very basic brief on power measurement. Okay. So where it is written that power measurement of the electrical power. Okay. Measurement of electrical power is an essential in industry. Okay, and as it is commercial or the even domestic applications or the appliances. Okay, so you know that I have already discussed the measurement of electric power is essential for industry. Why it is so essential? Because of that power factor. Okay, so if the power factor, there is an effect of the power factor with the voltage profile and the power loss, everything. Okay, everywhere that profile is there. That's why it is so important. The prior estimation, okay, the prior estimation and subsequent measurement of instantaneous and the peak power demands, okay, of any installations are mandatory for the design, operations and maintenance of the electric power supply network feeding it. Okay, so you know that importance. So definitely for what design, operation and maintenance, that three things are most important: design time, then operation times and maintenance time. So when you are designing one instruments, okay, so first thing is that how do you, what methods you are following for the design purpose. Okay, so mathematical steps are there, so that is known as the design. Okay, so what are the different design? Okay, so it design based on what? The design based on instantaneous and peak power demand, okay, of any installations. Okay, so how would you design the thing instrument that instantaneous and peak power demand based on that? Okay, you are doing that designing. After completing your designing, then you are doing that operations portion. Okay, operations means what? Then how it is operating. Okay, at that situation how it is working. Okay, that will be mentioned it, and that will be checking by the devices. Okay, so that is your operations. Okay, so it is perfectly operating or not. If it is not perfectly operating, that means after certain times what happened, due to the aging effect, due to the tenure of the operations of your instrument, then you have to use some maintenance work. Okay, maintenance work is required for the electric power supply network to feeding it, because in power measurement, so you can see that individually you are able to measure the voltage, you are able to measure the current. Okay, individually it is possible, but after that what you need to do? After that you have to go for that in you have to make it compact. Compact instrument it should be required, otherwise you are not able to measure everything. Okay, so compactness is important. Okay, so then who will decide that compactness? So definitely the design aspect. So that's why individual voltmeter ammeter you are not using. Okay, so we are using one dedicated instrument that is called wattmeter. Okay, so that wattmeter having capability to measure that voltage as well as the current. Okay, so you know, like your CTBT in my chapter, so you can remember that in CTPT, that CT I have also told as the protection purpose. Okay, that CT is connected. Okay, for the measurement of current. Okay, so also PT is installed for the measurement of voltage. So then by default you are connecting all of them and for measurement of the power. Okay, everything is there. Okay, so at the time of measuring purpose. Okay, at the time of measuring purpose, so power measurement by the CTPT also you have did it. So same process you can follow over there, but here the CTPT is not there. So you can say like that current coil and potential coil. So in wattmeter, two coils are most important. One is called current coil, that is the resistance. Current coil means it is directly connected with the series with your load, in between the load and the supply. Okay, so power supply is definitely required. So current coil, purpose of the current coil to measure the current. Okay, so current coil is installed. Okay, so in wattmeter both of the coils are already there, current coil and pressure coil. So current coil is connected in between the main supply and the load. Okay, so it is series with your system and it are able to connect the able to measure the current. Okay, current of it. So as it is connected in series, so definitely inherently the loss, that means the potential drop of that coil should be less. Means how would you reduce that potential drop? So you have to select, you have to select, so you have to design at the time of manufacturing of that wattmeter, design such a manner that that series resistance should be less. How do you make that resistance less? So one thing is there, so you can increase the cross sectional area of that current coil, that is possibility number one. And second conditions, you can reduce the number of turns. Okay, number of turns you can reduce, increase the cross sectional area. Okay, so that you can do. Also the cross sectional area increase means the conductor may be thick. Okay, so you can reduce the current drop, okay, through that conductor in current coil. And potential coil means pressure coil. Okay, so that also known as the potential coil, it is connected parallel with your supply, maybe load. Okay, you can say like that way. So which one is much more convenient? You need to connect parallel with your supply or parallel with your load. That will be coming to my next session. Next session means next section. Okay, so I'll discuss later, but potential coil is there, that is connected parallel with your system. Okay, and able to measure the potential. So after that what happen, you are multiplying both of them, so it is here voltage. So one multiplying factor also be there, that is power factor angle. For individual, all of you, those who are already did that basic electrical lab, so they can know that normally we are using two type of wattmeter. We are using unity power factor wattmeter and LPF, low power factor wattmeter. Okay, so that is used, you know, that for the measurement of transformer equivalent parameters. Okay, so coal loss component, then copper loss component, all kinds of loss component for calculating in the in the short circuit and open circuit test of the transformer. Okay, so where we are using this type of wattmeters. One UFC means unity power factor wattmeter, that is used for measurement of the copper losses. Okay, so where that low voltage side is shorted and high current is flowing through that low voltage side. Okay, another one is that is open circuit test. Okay, there where that high voltage is open. Okay, so that is done by the coal loss component test. So in that case we are using LFC. Okay, so the where is the power factor is quite less. So as per the convention, so some of the multiplication is there. So as per the designer or the manufacturer specifications of that wattmeter, so power factor angle also be there, that should be the multiplied with your V and I. So you are getting that value VI cos phi. Okay, so sometimes multiplication, another multiplication also be there, maybe wattmeter you are designed for 150 watt, you are designed for 300 watt. Another cases I have all seen up to in our lab, up to machine lab it is 600 volt. Okay, sorry, it depends. Okay, so sorry, I am wrong. So in voltage I am getting 150 volt, 300 volt, 600 volt, up to that. So significantly wattmeter having some of the rating. Okay, so how scaling is there. So if that increasing of the scaling, so again you have to multiply. Okay, I think all of you are able to understand that what am I discussing. Okay, so that's why that point is also important, the power supply network feeding to it. Okay, so it is also important. Then the next point is knowledge about the accurate estimations. Okay, so knowledge about your accurate estimations, calculations, and the measurement of electric power is thus of the primary concern of the design of the new installations. Okay, so all are important. So I think you are able to understand that estimations, calculations. So basically you can say like that, single word, the calibration. Okay, so calibration, definitely it is important. If you don't have that proper calibration with you, so you are not able to measure proper manner. Okay, so definitely we have to make an arrangement for the measurement of power that should enable both of the measurement. It should be the measurement of AC circuit as well as DC circuit. So first we are doing the power measurement in DC circuit. Okay, so first one is your power measurement in your DC circuit. Okay, that I have already told you that arrangement is such a manner. So first we can say two arrangements. So wattmeter having two coils. One is current coil, another one is your voltage coil. Okay, so here you can see that A means your ampere. Okay, and V is your voltage. Okay, so you are going to be measure it. So Vs is your source. So first arrangement you are making that ampere means ammeter is connected series in between the voltage source and your load. Okay, that is your load. And second case you can see that voltmeter is connected nearer to the load, across the load. Okay, so is there. Okay, and second case, this is case 1. In second case the voltmeter is connected across to your source voltage. Okay, so which one is much more convenient? That is our agenda. So when we are designing, when we are connecting for measurement of power, okay, which method you need to be followed, that is our main agenda. So here you can see the electric power. So electric power P is consumed by the load R. So it is already given that P is there. So it is consumed by load R. So that you need to calculate. Supply from a DC power supply. What type of power supply? DC power supply. It is known as VS. It's the product of the voltage. It's the product of the voltage across the load VR. Okay, so across the load it is VR, and the current flowing through the load is your IR. So current is flowing, it is called IR. Okay, so you know that IS is your source current, IR is the current through the load, IV is what? IV is the current passing through your voltmeter. VR is what? Voltage appear across the load resistance. VA is what? VA is the potential drop across your ammeter, and VR is same both of the cases. Again it is your load R. Okay, so total power, output power consumed by the load is what? IR is coming passing through this load resistance, and VR, V into I. So VR into IR is your consumed power, that means product of the voltage across the load and current flowing through the load. Okay, so that is your consumed power. Okay, then you can see. So I think all of you I able to understand case 1 and case 2. Which one is much more convenient? We are going to be studying. So after that you can see that current through the voltmeter is what? The current through the voltmeter is IV equal to VR by RV. Okay, so definitely VR by RV. Okay, so the RV is the internal resistance of the voltmeter. So RV is the internal resistance of the voltmeter. IV is passing through that voltmeter. So RV is the internal resistance. So RV, so what is the value? IV equal to VR by RV. Simple thing. So power consumed by the load. So you need to calculate that VR IR. So what is the value of VR? VR is same. VR is there. VR into IR. IR equal to what? IS minus IV. IS minus IV. Okay. VR into IS minus IV. So it is coming VR into IS minus. So it is coming multiplying that VR into IS minus VR into IV. So then you can say like that, what is the value of IV? IV equal to VR by RV, so you can replace that value. So it is coming VR into IS minus VR square by RV. So VR into IS means power indicated by the instruments. Okay, power indicated by the instruments minus power loss in the voltmeter. So VR square by RV means power losses in the voltmeter, and VRIS means power indicated through the instruments. Okay, so what power you are going to measure? So what is there? Power indicated equal to what? Power consumed. Power indicated means what? Power consumed plus power loss in voltmeter. Power consumed plus power losses in voltmeter. It is coming from that expression. Minus term is there. You can shift that minus component to the left hand side. So it is coming power indicated equal to power consumed by losses in voltmeter. Then case 2, the voltage drop across the ammeter. In case 2 means voltage drop across the ammeter is what? IR into V. So it is coming IR into, sorry, RA, not VA, that is RA. So VA equal to IR into RA. So VA equal to IR into RA. Then where RA is the internal resistance of the ammeter. So what is RA? RA is internal resistance of the ammeter. Then power consumed by the load. Okay, then power consumed by the load means what? It should be same VRIR. Previous case we were also find out VRIR. So VRIR equal to what? VRIR equal to what? VS minus VA. Definitely VS is the source voltage. VA is the drop through the ammeter. So it is coming VS minus VA equals to VR, because as per the KVL, so VS minus VA minus VR equal to 0. So VS equal to VA plus VR. So what is VR? VR equal to VS minus VA. So that's why it is written VS minus VA into IR. So you can multiply both of them. So VS into IS, sorry, VS into IS minus VA into IR. So it is coming VS into IR minus IR square into R. So how it is coming? Power indicated by the instrument minus power loss of the ammeter. Thus power indicated, so thus the power indicated. In second case, power consumed, both of the cases power consumed plus losses in ammeter. So first case it was losses in voltmeter. Okay, first case losses in voltmeter, and second case losses in ammeter. So which measuring devices is nearer to your load, that losses is considered. Okay, the total power indicated means power consumed plus losses in voltmeter for the first case, because voltmeter is nearer to the load. The second case, total power indicated equals to, so power consumed plus power loss in ammeter. Okay. Ideally in theory, okay, so ideally in theory we consider the voltmeter have infinite internal impedance. Okay, so because internal impedance infinite means there is no current drop through the voltmeter, and ammeter have zero internal impedance. Okay, so one can observe that the power consumed by the respective instrument go down to zero. So if both of the cases is zero, so there will be no loss. Thus in ideal cases, two arrangements give you the correct indications in the power consumed by the load. Ideal cases both should give the same result. But in the practical condition, that is more important. Practical condition, the value of power loss in instrument is quite small, if not totally zero, as compared with the load power. Okay. So therefore, the error induced in the account is small. Okay. I think ideally both give you the same, but practically when you are going for the practical cases, so both the cases will get quite lesser power. So some of the power will be lost. Okay. So we are doing the same arrangement and taking one example so you can understand, all of you can understand. So what is that example? So two incandescent lamp with 80 ohm and 120 ohm resistance are connected in series with a 200 volt DC source. So 200 volt DC source is there. So incandescent lines are there. So find the error in the measurement of power of 80 ohm lamp using the voltmeter with internal resistance is 100 K. Okay, and ammeter internal resistance is 0.1 mega ohm. Milliohm. Okay. When A, the voltmeter is connected nearer to the lamp. First case, the voltmeter is connected nearer to the lamp. So which diagram? Voltmeter is connected nearer to the lamp. First diagram. Okay. And when the second case, ammeter is connected nearer to the lamp, the voltmeter. Okay. So that you need to do. So diagrams are there. So assuming both the instrument to be ideal, okay, so both the instrument ideal, the voltmeter will having infinite impedance resistance, impedance, and ammeter with zero internal impedance. So current through the series circuit should be what? So if it is infinite, so it should be like that 200 whole divided by 80 plus 120. Definitely voltage is there. So 200 whole divided by adding of these two. So that amount of current should be flow ideally. So it is 1 ampere. It is your source current, I think so. The power consumed. So the 80 ohm lamp. So 80 ohm lamp is there. So I square R loss would be there. So it is 80. It's not the ohm. It is watt actually. Okay. So 80 into I square IR. Na? So it is watt. So 80 watt is there. Okay, so it is, you can see the diagram. IS is there, 200 volt is there, so 120 ohm is there, 80 ohm is there. So and internal resistance 100k and it is 0.1 milliohm. Okay, however, considering the resistance of the circuit equivalent look like that. So first case the supply current ammeter reading. Okay, first case we are nearer. You can see voltmeter is connected nearer to the load like that. So it is here. So voltmeter is connected nearer to here. So all of you calculate in your classwork copy. Okay, so all of you try to calculate it so you can easily understand what is the actual value. Okay, it's simple. All of you please calculate it. Okay, so I think you are doing the calculation. So first you collected the supply voltage. Okay, so supply current you need to find out. Okay, so IS. So IS is there. So if you add them, so both are parallel. So you can say like the supply voltage whole divided by series lamp 1 plus ammeter. So we are in series. Then these two are the parallel. Okay, so finally you are able to get that current is coming 1.0003 ampere. Okay, actual current of that 80 ohm lamp. So now we are find out that current, that means IR current you need to go to find out. So total current into 100k whole divided by 100k plus 80 ohm, that is getting. So how much current is there? IR is 0.99. Okay, so IR is 0.9995. Okay, IR. So actual current is 1.003 ampere and IR current is means it is source current. So IS is there and IR is 0.9995. So how much current is lost through the, means what is the value of IV? So if you subtract both of them, so you will get the value of IV. So this amount of current is lost through the voltmeter. Okay. What is your voltage across that 80 ohm lamp? So voltmeter reading is VR equal to IR into 80. So multiplications is there. So VR equal to IR into 80. So IR is there. Okay. So that you have calculated IR into 80. So it is 79.965. So the actual power consumed by 80 ohm lamp is VR into IR. So it is your actual. So it is coming 79.922 watts. So how much percentage error? Okay, so the power consumed indicated by the 2 meters. So voltmeter reading into ammeter reading. So it is coming 79.986. Okay, so how much percentage error is there? You have to calculate it. Okay, then the condition number 2 means case 2. Okay, in case 2, what happened? That equivalent circuit, you can understand that in case 2, IS is there, so ammeter is nearer. Okay, and the voltmeter is further than your resistance. Okay, so it is 80 ohm and I think it is 120 ohm lamp. Okay, so both are there. So now again you have to calculate the supply current. So IS, how much value of IS is there, supply voltage, equivalent resistance, that you need to calculate. Okay, so you can replace all those value like your 200 volt, 120 ohm, IV 100k, then here everything you have replaced. So 0.1 million, and finally IS equals to coming supply voltage whole divided by series of lamp 1 and parallel the voltmeter series of the ammeter and the lamp 2. Okay. So finally we will get that amount of IS. So this is 1.003. Here it was 1.0003, it is coming 0.003. Quite difference is there. So current through this 80 ohm lamp ammeter reading, it is coming 0.9995. So here ammeter reading also be actual current 80 ohm lamp is same. Okay. So voltage across 80 ohm lamp is 79.96 volts. So here 79.962 volt voltage across 80 ohm, more or less same. So then the voltmeter reading is 80 volt. That IV into 10k na, IV into 10k, so IV equal to IS minus IR. Okay, it is your IS minus IR. So that is your IV that you need to find out and multiply. It is coming 80 volt. So here you can see that actual, sorry, voltmeter reading. So actual power consumed for 80 ohm is 79.96 into 0.9995, it is 79.92 watt. So again it is same 79.92 watt. Now the power consumption in the indicated by the 2 meters. So it is coming voltmeter reading into ammeter reading. So 80 into 0.9995. So it is coming 79.96. So it is coming 79.96. Simple difference, very simple difference. So ideal power. Now we are comparing both of the cases, case A and case B. So ideal power, both are the same, both are same. Actual power approximately same. Okay, so meter indicating it is 79.986. Second case it is 79.96, more than rounded. So what is the error for the ideal? It is 0.0175, and how much error is there? It is 0.05. So how much percentage it is for the case B, means this case. So this case means case B. This case having percentage of error is 5%, and first case the percentage of error is 1%. Okay. So which one is much more convenient? That case 2 is much more convenient. Okay, so voltmeter is nearer. Okay, so voltmeter is nearer first case, and second case voltmeter is ammeter is nearer. Okay, so when voltmeter is nearer to the load, that will give you much more accurate results. So from this table you can conclude, compared to your ammeter is nearer to your load. Okay, so you can understand, all of you can understand. So then what can I conclude? What can I conclude from this study? The conclusion is that power in DC circuit can also be measured by wattmeter. So wattmeter can direct indicate the power, and there is no need to multiply the two reading in that case when the ammeter and voltmeter is used. Okay. The type of wattmeter most commonly used to such power measurement, that is called dynamometer type. So you know the construction of the dynamometer type. In my previous lectures I have discussed already about the basic operating principle, basic construction, okay, of the dynamometer type instrument. So wattmeter is normally measured design like your dynamo wattmeter is your dynamometer type dynamometer because it having ability to measure voltage and current both in both DC as well as AC. Okay. It is built. Normally, dynamometer is built by the two conductors. You know that two coils are there. Okay, two fixed coil, another one moving coil. So connected to a fixed coil. Okay, connected in series. Fixed coils are always connected in series and positioned coaxial. Okay, so coaxial means cylindrical. Okay, inside of the cylindrical, coaxially with the space. Okay, between them and moving coil. So that is condition number one. And condition to the moving coil placed between the fixed coil and the fitted with the pointer. Definitely fitted with the pointer. Such a construction for the dynamometer type wattmeters. So that construction is followed for the dynamometer type wattmeter. It can be shown that the torque produced by the dynamometer type is proportional to the product of current flowing through the fixed coil and the moving coil. So that portion I have already discussed. Okay. So how it is coming, multiplication of both of the current in the fixed coil and the moving coil. The fixed coil generally refer the current coils. Okay. The fixed coil generally refer the current coils. So fixed coils are what are the current coils. Carry the load current while the moving coil. Next one is a moving coil. Moving coil generally referred as a voltage coil. Okay, so moving coil is a voltage coil that is rotating inside the coaxial axis. Okay, so carrier the current that is proportional via the multiply resistor that is called RV. So here you can say multiplicating resistor RV. Okay, rating has changed. Okay, so which rating is there as per that value RV has been selected of the moving coil. So pointer is there, moving coil is also there. It is a moving coil. Okay, this is a moving coil. The voltage across the load resistance R. So voltage across the load resistance is given as a R. As a consequence, the deflections of the moving coil is proportional to the power consumed by the load. So power consumed by the load will decide the deflection because total current is passing through this fixed coil. Then it will interact with your moving coil. Okay, so you can see the fixed coil. So that these two are the fixed coil. Okay, in terminals of the fixed coil. So V2 then it is flowing like that way and coming back to, and the moving coil portion. Sorry, moving coil portion. That means your measurement of voltage. Okay, that is there. Moving coils are there and pointer is there. So in interaction between that voltage, sorry, interaction between the fixed coil and moving coil. So pointer is deflecting. So it is fixed coil number 1, it is fixed coil number 2, and finally we are able to get the actual values of measurement. So it is the basic construction of dynamometer type wattmeter. I think all of you are able to understand. So I think till now there is no such any confusion, okay, and any doubt, because that is enough for today's session. Because in my last session, next session, we will conduct some test. Okay, so that's why I have make it fixed